Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in the last lecture we have studied that how we have estimated the electrolytic cell of molten NaCl, and we have did the diagram, and yes, we have calculated and we have draw the net cell reaction also. So now what we are going to do is, now we are with the help of that principle we are talking about the Faraday's law. And what is that? Let us see. There are basically two Faraday's law, that is Faraday's first law and the Faraday's second law. So let us talk about Faraday's first law and let us see what does it states. Faraday's first law states that the amount of substance that undergoes oxidation or reduction at each electrode during electrolysis is directly proportional to the amount of electricity passed through the cell. It means, in the previous lecture only we have studied the electrolytic cell of molten NaCl. In this case, we have studied that at anode the chlorine molecules are being getting liberated, and at cathode the sodium atoms or the sodium atoms are being getting deposited. So this is proportional to the current when passed through the solution, or when the current is passed through the cell. If more amount of current is being passed through the cell for more time, then the electrolysis will happen much more effectively. So this is what the Faraday's first law says, that if you pass more current through a solution, then the electrolytic cell will occur more, and that is for more time also. So therefore, for what I could say is that if you increase the current, then the electrolytic process of a particular electrolyte will always increase, and it depends that how much amount of weight that has been deposited on the anode as well as on the cathode is also dependent on the current. So now let us talk about the second law. The second law states that when same quantity of electricity is passed through different electrolytes arranged in series, then the masses of the substance that will liberate or will get deposited at the respective electrode is directly proportional to the chemical equivalents. So let me give you an example to make you understand that how is being second law stated by the Faraday. Suppose if I consider two solutions, one is NaCl solution and one is ZnCl2 solution. The both are being connected in series. The same example as we have did for the electrolytic cell of molten NaCl. But in the case of molten NaCl, there was only one cell of molten NaCl, but now we are taking the NaCl solution as well as ZnCl2 solution. So in this case, suppose if I have passed electricity through the external circuit, that is through the battery, then at a respective anode a particular molecule will get liberated or deposited, and at a respective cathode the particular chemical in the form of atom or in the form of gaseous state will get deposited or liberated. But there are two cells, one cell is of NaCl while the other cell is of ZnCl2. So in this thing, the one which has higher equivalent weight will have the more amount of the solution, or the more amount of the atom will get deposited on that particular cell or that particular half cell. Suppose in this case, suppose if I talk about if Zn, that is if zinc has more equivalent weight than that of sodium, then we could observe that at particular cathode of the zinc in which it is been dipped, the electrode will have a deposition of more zinc than that of the deposition of sodium on its cell, that is on the NaCl cell. So this depends on the equivalent weight. Even though the same amount of current is passed through both the solution, when this both solution or when these two cells are being connected in series. So because of help of this, we could estimate that, as we can see, that is the reappearance of the metal or the reappearance of a particular chemical that are appearing on the cathode and anode by arranging too much of and so many of half cells, and by observing we could estimate that which chemical would have the higher electrochemical weight. So this is the theory that was been shown by and was been elaborated by Faraday, and because of help of which the Faraday first law, which states about the weight of the substance that will get deposited on the basis of the electricity, the higher the electricity, the more will be the weight of the sodium or the main cation or anion that will deposit on the respective electrode. While the second law, that is the second Faraday law, it states about the equivalent weight. The more the equivalent weight, the more will be the weight of the particular substance will get deposited if multiple half cells are connected in series. So based on this two law, they have formulated an equation which states that W is equals to Z I T divided by 96500 coulomb. So in this formula, the W means the weight or the mass of the substance that has deposited on the respective electrode, while I is known as the current, T is known as the time, and Z is known as the equivalent weight. And while this integer, that is 96500, it is nothing but the Faraday constant. And how does it have came? Since you know, for 1 mole of electron, it consists of 6.023 into 10 raised to 23 number of electrons. 1 mole of electron will contain 6.023 into 10 raised to 23 mole of electron, and 1 electron has a charge of 1.6 into 10 raised to minus 19 coulomb. So this number of electrons, when multiplied by 1.6 into 10 raised to minus 19 coulomb, will give you an overall charge of 96500 coulomb. So that's the reason this states that 1 mole of electron will consist of 96500 coulomb, that is known as a Faraday constant. And with the help of this formula has been evaluated, and this would be very much helpful to estimate what would be the weight or what would be the mass of a particular substance that has been deposited when this much amount of current is passed in the time interval of this much, and which has an equivalent weight of Z. So this was very much easy. So based on these two things, we have equated and formulated in a formula. So thank you friends for watching this video. I hope you have liked this video, and you have to get much more information what is electrolytic cell and what is electrochemical cell. So thank you friends, and please share this video with your friends, and don't forget to subscribe Ekeeda channel. Thank you so much.